So we're almost at the end of the concert. Did you all have a great conference?
Yes.
So we're after lunch. It's hard for, for a presentation to come after lunch, but I can promise you this is going to be worth it. I'd like to, in a few minutes, introduce Brian Byers. He's a science teacher at DeWitt High School and his students. This project is one that I approached Brian about a year ago. And we had this idea that, well, what if we could have the kids build a 3D printer? And so they're going to show you what they've done here in a second. Just a little bit about myself, and then Brian's going to take over from here. My name is Kim Mathiot, and I'm from the Michigan Department of Education. I work in the Office of Assessment and Accountability. That's what I do for my day job. But my passion is promoting and supporting creativity in K-12 education, as well as entrepreneurship and innovation. So the idea here is that what we wanted to do was to put the technology in the hands of students, put the learning in the hands, minds, and hearts of the students, and give them a chance to really show what they can do. And they're going to show you today. So without further ado, I'm going to stop talking because you didn't come here to hear me. So I'm going to turn it over to Brian and his students.
Hi, thank you for coming. I know it's our last session before this is all done, so I appreciate it. I was worried that nobody would show up and we'd be very sad. I want to give you just a brief overview of our program, and then I'll turn it over to all the wonderful people behind me, and they will talk to you for a bit about what they do, and then we will just open it up to questions. That tends to be our MO when we're speaking, and it tends to work really well for us. So if you have questions or you start thinking about things about either the program, the process, what they've gone through, feel free to ask. About 2 or 3 years ago, I was approached by the DeWitt Creativity Group. I don't know if you've heard of that. It's a very nebulous organization in DeWitt that really pushes for more creativity in education. And one of their concerns, and mine as well, is how we're slowly crushing our students with all of the testing and standardization and the new objectives. And as a science teacher, I just kept feeling like it was getting poured onto me, and I was sad. And the creativity group came to me and they said, we noticed you have an empty lab. Do you have any ideas of how you could use that in your school? And I was like, oh, well, I have lots of ideas. And they said, well, will you run with one? And so I did. And what I made was what we now call the DeWitt Research and Development Lab. And we started with a focus on alternative energy, and we branched out from that. But basically what it is we take students in, and during one of their class periods, they choose something to research. They develop it, research it, and go through this kind of a really cool process. The issue with the course is it's as about untraditional as you will get. So if you have questions about how we handle different things, please go ahead and ask. And if you're totally uncomfortable or don't agree with lots of it, we're good with that too. We don't take offense at all. One of my teachers last night, we were at dinner, she's like, I really don't like that you guys do this. I'm like, we're good with that. We're okay that you don't like it. So we don't mind. But I made it to be totally untraditional because I didn't like what we were doing. And we've done a few different things. The first is I threw away all objectives. I don't have objectives. I don't have a curriculum in this course. The MDE has asked me to make a course that they can kind of show to people so other people can replicate what we're doing. I said I can do that, but it won't be my course. Because what makes our course special is the freedom that the students have to do what they do. And what makes it powerful is their passion that they go to with it and how they attack it. And when they get up here and talk, you'll see the learning and what they've done. So we started with a group of 12 to 13 individuals, all girls, one guy. And that was our trial run. Just whatever people happened to be around. I said, hey, would you like to do this really cool thing? They focused on alternative energy. They were focusing on algae growth and biodiesel and solar cells. Then the next year we ran this as an actual course. We had, 5 groups, 6 groups working on everything from a fusion reactor to supercapacitors, wind turbines, right? Just a ton of different things. And what we found is that when we let our students go, when I get out of their way, they do exceptional things. And another thing we kind of removed was time limits for them. So one of the things that people were amazed about at one of our conferences last time, and they'll probably talk about this as well, is you ever notice how seniors get done like a week or 2 weeks early, and you've got your juniors left? My seniors never left. So when my seniors graduated, they kept coming back to my course. They wouldn't come to anybody, but they'd come back because they were so impassioned with what they're doing. This year, as Kim told you, she said, hey, could your class do like a 3D printer kind of a thing? And I said, well, I'm sure that would excite people, and if they have a passion, we'll do that. I can't guarantee it. So when the class was forming last year, I said, hey, can 4 of you maybe do a group where you do 3D printing or something? And I had 12-ish who said, yeah, that's what we want. And I was like, I only want 4. And so we ended up taking a few, but we actually have a multitude of groups that are doing this. And so we use 3D printer to bring people in because people like 3D printers, but our actual process is so much cooler. The one problem we have is like when the Mechanifor group comes up here to talk, which I'm sure they'll get a chance, right? You won't understand anything they say, all right? And that's okay. Because our class had 3 objectives when we started the course, and they'll talk about this. The first one is they had to pick a project that they thought would change the world. Like, I don't care what you do, but it has to change the world. Their second part was to make me $1 million. We're waiting on it. I have faith. Almost there. And I think I might have lost the third one.
I think it's make you $1 million.
I think after the million, you're good.
I have pretty much stopped listening after I got to that point.
Oh, and get
Maybe I'll
published.
remember it.
Yeah,
Huh?
don't stop.
Well, that's just something you got to do. But we're very research based. Like they do research all the time, and then so we document everything. We try to make sure we have it all. And like what he just said is one of their things is they have to be published by the end of the year. And people always go, how do you make people publish if you're not grading them? And one of the things we do is we don't want grades to be the goal. I don't want them to be saying, I gotta get an A, I gotta get an A, I gotta get an A. That's not my plan. That's not what we want. I want them to do it because they want to do it. I want it to be intrinsic motivation, not me dangling a mythical grade. And people ask how it works. I go, I don't know, it just does. I go and I turn them loose, they go. And you'll see that today when they talk. You know, I think I'll just get out of the way because I'm sure you'll have lots of questions for me later, and I can break down our whole process for you. But anyway, I'll turn that over. Sam will go first, and he'll kind of give you an overview, I guess. Right?
Yeah, well, yeah.
So I'll talk to you more later if you have questions for me.
I'm Sam.
I'm Chris Ruby. I'm a senior here at DeWitt. I'm Evan Swift. I'm a senior at DeWitt.
I'm Tyler Brzezowski. I'm a senior at DeWitt. I'm Andrew Stein. I'm a senior.
I'm Cam Clemenson. I'm a senior.
I'm Jacob Wozniacki. I'm a junior at DeWitt.
Jonathan Theoret. I'm a junior.
And we also have 2 students in the back doing mechanical course.
I'm Devin Lake. I'm a senior at DeWitt.
I'm Joshua Duck. I'm a junior at DeWitt.
There we go. I know. So, as of right now, we came in. This is like our story. I'll give you a brief synopsis of what we did. So the first day, we all knew we started with a 30-minute class. It was our seminar at DeWitt. Everyone has it. It's your homeroom. You're there for 30 minutes. And all of us, or most of the seniors, are all there together. So what we did, first day, we knew what we were getting into, basically, that we were going to have a research project. We just didn't know exactly what we were going to research. He came up to us, like he said, and said, okay, here you go. You're going to do 3D printing. Who wants to do it? We all raised our hand. Right away, we had to find the printer. That's the one we bought. That's the one that we thought would work the best for us. And we bought the printer. Then we had split up into groups. So there's about us, there's about 4 in the 3D printer, then we have a 3D scanner, and then we have like the programmers, the ones that are behind it all, the ones making the kind of Google SketchUp and all that. So that's how we sort of split up right away, probably in the first 9 weeks, because you're only meeting for 30 minutes, and it was not fun meeting for 30 minutes, because we wanted to be there for 2 hours, we wanted to be there for 3 hours, and you have to go to calculus afterwards, you're like, I just want to stay and work, but you can't. So like the first 18 weeks was all homeroom, 30-minute class period. And then after Christmas break, we came back and we have a 2-hour block now that we can work on it because it's an actual class, our schedule. So now we're working on it for 2.5 hours with our homeroom. And then when we started that, right after Christmas break, we had just finished the printer basically. Like we were almost done, we were just doing the motherboard, like finishing up. And then we realized with the amount of time we had, we can do so much more. So we started just developing. We're gonna try. Our original goal was to make another printer out of our printer, and we did that. We have pieces. I passed some around. If you saw like the feet, those are all usable parts. The nuts, those are all usable. And then we have an extruder bed that was also usable. We have a ton of other parts back in high school. So that was like our first goal for the 3D printer. And the scanner, we can, if you guys ready to do that? Or,
Yeah.
if anyone wants to volunteer themselves to be scanned and like you can see like what we can print. I saw you first. Sorry. Oh, we can't.
That's how it works in the classroom.
All right, pause. Yeah. While that's going on, we'll keep talking.
Where do I go?
You can just hang out over there.
Just look like us. I don't look this snazzy.
They'll take care of you. So the 3D scanner, they'll scan an image and then we'll put it in like a scanning program and eventually be able to convert it to be able to print. And so then you can print the actual head, like his head or his torso and up, and you'll be able to tell it's him. It's really accurate, and you'll be able to like see that's his face, his jawbones, his shoulders, just like that. But it'll be obviously not his size. And that's the scanner part and the 3D printer part. But there's also there's also a way different way to look at this class. Like, yeah, we're making this, we're researching this, we're making a paper, but like Mr. Byers, our teacher, said, there's a project-based learning that's behind this. That's what our, like, that's another thing that we're doing. Like, we're doing research, but people are researching us, I guess you can say. So, with the project-based learning, we don't have grades. We don't, like, we'll all get A's unless you are not, like, you're just messing around or you're going to get an F. It's either A or F, but most of us will all get A's. We've all put in a ton of time, and that's what it is right now. But with, like, again, the project-based learning, it's not like the typical course structure, obviously. We don't have a test every Friday. We don't have a quiz every Tuesday. We're not studying for the ACT in the class, but you're so far past that. We've all been through those classes, but now to be able to stand in front of 50 to 70 people and talk about what we've done, to have like the critical thinking skills to make that, all the problems we've ran into, and all of that is like way past what school is. To be able to like, teach people, to be able to talk to people, to be able to go places, to see things with what this has brought us besides just being in class. To get an A, it's like so much more than that as of right now. So do you guys have any quick questions? We do like to do a lot of Q&A because that opens us up to a lot of your ideas as well.
I have a question. Could you rephrase it again? How many different? You said 3 different groups.
Yeah, we
what
have
are they again?
We have
The
a scanner.
scanners? Okay.
3D, like the people that put it together like that, and then the program.
Programmer. Okay. Thanks.
Oh yeah, and Mechaniforce, but that's different.
In terms of the printer itself, everyone that deals with this printer is broken up into, as Sam said, 3 different groups. We have the people who program, edit our programs so we can print more accurately, do things like that, and then also write up things for us to print. Chris Ruby here is phenomenal with CAD. Evan Smith's also phenomenal with CAD. And we have people who are developing those programs as well in order for us to print other things that people ask for. And then we also have the people who actually sit here and tinker with the printer all day long, troubleshooting, fixing things, changing things to make it more accurate, make it more productive. And then there's the scanner group, which you'll see when we get it working, hopefully, that have been messing with that and trying to make it so that way we can actually take an object that you own or you have and create a 3D rendering of it and then print it instantly here.
There's a question. Yeah.
Do you have to copy something, or can you start from like scratch?
Yeah,
Build something on CAD.
You can definitely start from scratch. If we go SketchUp, that's what we created. I don't know if you saw the little hole, like shooter bed. We drew that up. Like we started that. You can start anything like the
keychain that was passed around as well.
The Batman. You can make anything out of it. You can start anything up on your own.
that scanner, it looks like an Xbox.
It
Yeah,
is.
we,
Connect.
First day of class, Sam said we need an Xbox scanner, and I'm like, well, I have one, and we hacked it. And, I mean, we're kind of getting away from the Q&A right now if we start this, but it's just a normal Xbox scanner, and we had to download some programs, and you have to pay for each month, but we have a lot of emails, so we get a lot of monthly trials. So. So, you guys have emails, you wouldn't mind. But yeah, you want us to do it right now?
No, yeah, we can.
Yeah.
I guess we can come back up.
Come back up.
As we're on the scanner, we can.
Where are you guys planning on getting published?
We are actually in the development of a research paper, and all the problems, everything that we've done, all the project-based learning, everything that we've like talking here, going everywhere, like the other presentations we've been at.
Ask Mr. Byers where.
You know where?
And we're gonna try to get it.
Oh, Ruby, what did we use last year?
We're gonna try to get into like a magazine or a newspaper,
I
like a
forget.
professional.
We found one last year that we really like. We've tried different ones, and I'm sorry I can't remember off the top of my head right now. I thought maybe Jacob or Chris would remember. I knew you wouldn't see them.
If you guys want to watch the process, it'll be up on.
But it was one that was mainly for high school students, and it was done. They like peer reviewed it on their own, like the group does. Are you gonna go around him?
Yeah.
Oh, that's gonna be crazy. I remembered the third thing, by the way, in case you wondered. The third thing I told them is whatever they're researching or doing, they have to know more about it than I do within a week.
Perfect speed.
So, like the 3D printer, people will ask me questions about this often, and I'll just be like, their knowledge has passed mine very quickly. The Mechanophores passed me in days. Yes.
There's all kinds of different contests and things that these guys
Yes.
could enter, or do they enter all of them?
You know, we don't. It's really,
You know you're getting something.
we could. And we've talked before about, like, ooh, should we enter a science fair or...
There it is.
And we actually had a group last year who got super upset. Not that they weren't in a contest, but I fill a role in this as a facilitator and a motivator. So the way I envision what I do is I try to get them whatever they need to do what they want to do. So like the Mechanophores came to me and they said, here's a list of all the stuff we need.
Right.
And then I have to figure out ways of finding that or procuring it. Or Wozniewski, when he was doing his fusion reactor last year, it was like, I'm having trouble with this. And I go, here's the number to the cyclotron at MSU. Call. Have a good, so I try to push them, and I try to keep them motivated. So last year I made a mistake. I didn't know it at the time. Our supercapacitor group was doing great work with their supercapacitor. It was wonderful. And I saw this lady who won a $40,000 scholarship.
Yeah.
No, I couldn't get to work with them. They were so upset and so mad. They were like, we did that a month ago and she's getting paid and we're sitting here. You remember that? Oh my God.
So unbelievably something to use that in his mind. People, he really broadcasted it, and people gained interest, and they paid it. While we were sitting right at the halfway point between where he started and where he was going to finish, and we just hit a brick wall in terms of funding.
And for me, it was very amusing because he would be like yelling at the computer, "Stop mocking me!" This guy would be making all these different arrangements. And he's like, "That's what I wanted to do." And I really feel like the guy's personally teasing me.
But I've been running up an active field science.
Yeah.
That I've been doing it with, but it's like 7th and 8th graders.
Right.
But we've entered some contests and they really got kicked out of that.
Well, and I think we talked kind of about it, and I thought it, but again, one of the things I really, I do whatever they want, first off, but one of the things for me is always, you learn to learn. You learn about whatever you're passionate about because you want to do it, not to get the A or to get kind of so. I told a person yesterday, I go, it is validating when we get to go to a conference and talk, and people are like, wow, how much did you guys prepare for this? And they're like, he told us last night to show up, and you know, and they're like, what? And, but anyway, sorry.
Okay. So usually when we scan, we have like a spin turntable, and this doesn't move, so it's a lot more exact. But it actually turned out pretty well. Yeah, this is our program that we got free, but you know, let's try it out. So I don't know if you guys are paying attention, but when we first printed, there was a couple holes in space that the scanner didn't pick up, because obviously an Xbox scanner isn't the most precise scanner. But
it does work really well though. It's got just these little lasers that just shoot out, and then this thing picks it up and then just recreates the image, which is pretty smart.
yeah. So there's a program on this program that it fills the holes for you, and then we can add color and check it out.
Well, you can tell that's it, can't you? If you were to pick a guy in the room, that's it.
And the cool thing,
yeah, that's scary.
The coolest thing is that, so we take this image and we save it and we put it on a file and we send it over there and they can print a bust of your head. That's the coolest
And it
part.
would look, like I said, it would look like that white mold where you'd be like, okay, that's me.
Right.
And
How
you'd be able
long
to-
would it take to print? I
Oh,
mean,
we don't.
Well,
Depends how big it is.
Yeah.
okay.
Could
Did
you
you have to have
print a
those
piano?
colors of stuff?
Yeah,
or
you don't have
print
to.
it when it's done?
We'd paint it, we'd print it in white.
Yeah, so you just print in this basic blue.
Now, the first idea when Byers told me to like start looking for a scanner, what happened is that the scanner, he thought we would have to hack it, you know, open it up, maybe check it around, fix some stuff. Well, actually, we found this program which just does it all for us. I mean, we just scan it, and it takes like 30 seconds. So,
Now, since this is research and development, one of the problems is that we couldn't scan a pencil, but we could scan a person. So now we're trying to figure out how to precise the lasers, I guess, is the word I'm looking for, and be able to scan a pencil. So we got 10, 12 weeks to do that. So
Yes.
What was the name of that program?
scan it. You see it right here on the bottom.
But I can't.
Oh, skin it.
it's
Okay,
actually
thanks.
the program. There's a like 9-year-old boy showed this photos like online.
Oh yeah,
And then
that's how I found the tutorial. But yeah,
so we feel smart than a 9-year-old kid and doing it. So.
Yeah, it's right in the center.
How long did it take for you to produce or create the printer itself?
Well, we started in the beginning with like a 30-minute time range. It was like, okay, we can't really do much. So it probably took us, we could do it in probably 2 to 3 days now. But in like the original one, it probably took 2 to 3 weeks. But that was just the time restraints. But if we had like 3 hours a day, we could get that done easily.
They'll actually tear that thing down quite frequently, like not all the way to, but like today when people were walking in, you probably saw them. They had things unhooked from last night, and they literally took apart this whole part to redo it and make sure it was all clean. Like as we were sitting here and people were piling in, they were doing that. So they've become kind of adept.
So,
Did you start just from scratch or with a kit?
We
Or
buy a kit.
One of my favorite parts of this process, and they won't tell you because that's how boys are, but they none of them know how to solder, or they didn't, and it just came as pins. So like a USB plug had nothing in it; it was just plastic, and so they'd have to solder the wires, solder the pins. This whole board, they had to solder everything to it, but they had no idea how to solder, and that's part of the course. Part of the course that we push is that they have to teach themselves everything. You know, because like I said, they're supposed to be past me rather quickly, and they have to own it and learn it on their own if they want to know it. I go, well, we had a young lady last year, Madison Schmidtman, and I go, and she was studying piezoelectrics. So piezoelectrics they create electricity by pressure. And so her group, which one of them is still in our course this year, they made a charger for their iPhone that went into their sole of their shoe. Okay, but it took a tremendous amount of soldering for them to do it because they just got all these piezos and they had no idea how to solder, and so she taught herself how to solder. And she was doing all this stuff with USB, so she learned really fine soldering technique. And I said, go ask Madison. She'll come in one day during our homeroom and she'll teach you guys how to solder if you'd like. And so she came in and she's teaching them how to solder. And then they're like, well, would it be too much to ask? Could you just solder those points? And she's like, this once I'll solder for you guys. And so she's like, all right, so give me your solder. And she goes, and you go like this, and put them on, and there you go. And they're like, and they're like, do these next parts. And she's like, here you go. And they're like, oh, good, thank you. We're pretty good because we're not going to have to do a lot more soldering. And I'm behind her holding up the bags of like connectors. And she's like, because she had to do all of that. But they got to see Madison as a dancer and intelligent and nice, but she doesn't get a lot of respect, I think, for her intelligence. And these guys got to see her in an incredibly new light. You had this gorgeous girl sitting here teaching them how to solder and doing all this mechanical stuff and just, changing their whole frame. And then Tyler, I think, actually became the soldering. Like, he literally sat at a table. They tore apart like 5 printers, and he was soldering to their motherboards over and over, trying to make sure he had the process down before they had to solder to this. So, sorry to jump in.
The question I had is, you guys were talking about earlier about funding. Do you give them any is there like a grant, or your school gives money to some of their projects to some extent?
It depends on the day.
Okay. Yeah.
I mean, really. Last year we funded a lot of things ourselves.
Mm-hmm.
So the supercapacitor group wanted a DVD burner. Like, they actually used the laser in it to make it. And I was like, well, I could probably find you funding. It's going to take me a few weeks. And they're like, screw this. And they went out and bought a DVD. They just were like, we can't do this. We worked like a concessions booth to fundraise a little. For the printer, I actually wrote a grant to our athletic boosters and said I'd pull some out of my supply budget. One of our goals with the $1 million was not for me, but I tell them, I go, I want this to be a self-funding operation. Now, the 3D printer has helped with that because we are getting requests almost daily from teachers who say, hey, I need this. Can you help me out? Can you guys do something? And so, we had our first sale. We had a teacher he does a lot of gaming in class to teach us history concepts. He's like, I don't have any of these little pieces. And he goes, could you guys do something with this? And they're like, sure. And they actually designed it themselves on Google SketchUp to look like that and printed it out, and he paid us $5 and we have it hanging on the wall. We made money.
But now we're trying, that's making us $5, $10. But now with Mrs. Mathiak, we're trying to make, not make a lot of money, but we're with making our own funding. If we're trying, over the summer, once we get a base thing, like you said, the seniors aren't leaving, which is true now. We're going to try to make a base program where we can buy the kits and bring in public schools like Detroit, Lansing, Grand Rapids, everywhere. If they want, their teachers, they want to get into the project-based learning environment, they want to get into the new technology and have this in their classroom and teach their students this. We'll bring them in, we'll take them to a 2 to 3 day course, and they'll pay for the kit, and afterwards they could leave it, they could come back to us for their IT troubles, everything that they need help with. If they go back to their school and their motherboard's not working, there's a yellow light and there needs to be a green light, how do they get it to green instead of yellow, stuff like that. And we're gonna, hopefully we're gonna try to do that over the summer, and we're definitely gonna have courses like that for 2 or 3 days with other school districts and other MSU, hopefully, and other, a ton of different school districts that help us, and that'll help us with our funding, and for the juniors next year with their projects, if they stay with the 3D printing or if they go on back towards the alternative energy side of things. But that would definitely help out in the funding side of things.
And now that
now that we've had about 6 months of like knowledge and troubleshooting, we're starting to turn it into a business. What Sam's saying. So we're our first step is to really draft a business plan and start turning this into a profit. Where, like you said, we're able to fund the future classes.
So yeah, we have made iPhone cases. We've made a lot of cool stuff, but now instead of going from like $20, let's see how we can go to $1,000. Let's see how we go to $5,000. Let's see how we can go to $10,000. Let's see how we can make a company out of us. That's what, like, we all have like goals, and that's why we enjoy coming to school. Like, as I can use for example, my French teacher is in the classroom, and we knew we were coming here. So a couple of days ago, I was like, okay, Mac, please try. I have to get this done. And I knew that the printer was having some problems. She's like, yeah, you're okay. You can go work on it today. But that was like, everyone wants to be here. Like, we love what we do now. Like, we enjoy coming to school. Like, wake up, okay, we have class, first hour, second hour, oh, we're in from 8:30 to 11. We're working on the printer. We love being there. We've learned a lot. We've taught a lot, and we've just comprehended a ton of different things over the time.
Yeah,
we're
really invested
cool.
in it, and so like after school we want to come back for another 2 hours. I take a class through our local community college, and during that time, while it's supposed to be online, I'll be in there working on the 3D printer, and I know Chris Ruby will be, and others too. So.
And last night, our printer, as you heard that they were in here trying to make it work again. Andrew Stein was there till 8 p.m. He got kicked out by the janitors last night. So like, you can tell, like, that's like the thing. Like, we all want to be here doing it, and then like some of the other schools, like this is like way above any of the 3D printing stuff. But like, say for Detroit, for example, like some of the kids like don't want to go to school. What if you give them the option to go work on this? What if they say, go in and say like, I just want to have fun at night. I just want to go out. I don't care about school. Then one day they come in and they're like, there's a 3D printer there. Well, now, Mom, I love that. Like, I want to wake up at 7 in the morning and go to school, go to English first hour. Oh, and then now I have my 3D printer. I want to be here. I love what I'm doing. Like, what if you were to do that for them? So it's like a totally different side. What if it opens up their minds to so much more? So that's what we're trying to do.
And not even 3D printing. You take that, anything a kid has.
I was just going to say, can we switch that to the mechanicals?
Right, yeah.
Like, to bring them, this would be a great segue. You're exactly right.
So these are 2 kids that also love what they're doing. They call it mechanical or something.
Yeah.
So.
Yeah. Me and Josh were also a part of the group, but when it was first introduced, he was like, yeah, who wants to work on the 3D printer? And a ton of them, probably 2/3 of the class, was like, yeah, let's go do that. And the rest of us like, all right, so what are we going to do? So we're like brainstorming, we're writing stuff down, we're looking up all the newest and latest sciences and technologies and energies that we can research, and we're right now like, well, all these things have been done, so let's just go find something really abstract and bizarre. So me, Josh, and 2 other people in our class, we went and we were just Googling the most cutting edge, brand new science we could find, and we found something called mechanophores, which are chemical polymers that change chemically under mechanical stress. So like, what they were hoping to do is put them in bridges. That way, like, as bridges start to bend or break, the polymers will actually break a little bit and then reharden and actually make the bridge stronger as it goes. So we were like, oh, that's awesome. Let's look into that. So we looked for it and looked for it and looked for it and didn't find anything on it. I could track it back to one professor at Duke University and one to Illinois. Those are the only people I could find in the entire U.S. that had any idea what it even was. So we're like, well, let's just ask them if they'll help us. So I sent an email to Duke, and I sent an email to Illinois. I'm like, they ought to help us. And within like 10 minutes, I get an email from Duke, and they're like, that's really expensive, way too hard. We don't even know how to do it. You won't make it. And I was like, ouch. All right, that was really depressing. So I'm like going around my house. Like an hour later, I get an email back from Illinois. They're like, oh yeah, sure. And they sent me their research, pictures, how to set it up, like this big long list on how to make it. They even sent me websites as to where I could even buy the materials for it, and like a list of everything. So I was like, it sucks to be you, Duke. Bunch of high school
Yeah, but we give out 120, 130 pages of just raw research information from them that we had to first read through. And by now we have all of our processes set, the whole cost analysis, everything down, and we've written about, I think, around 32 pages of just, steps we're going to do, stuff for our final research paper.
Yeah, because what they sent to me was just this big, long paper with pictures and numbers and words that I'd never seen before on it. So what I had to do was go through and teach myself chemistry, because the beautiful thing about that class is it's what you want to do. So like, I was forcing myself to learn chemistry. What kid goes to school to teach himself chemistry for fun? Like, I had to learn how to do chemistry to write that paper because I didn't understand their gibberish. I turned it into like a cookbook recipe. So that was something like my group could actually follow. It was intense. And then we've got other people in my group like researching ways to like turn like energy from waves going across the ocean into an up and down pulsing electrical source to power things using the motion of the waves. That class is like, Byers kind of came in and he had the idea of 3D printer and it drew a lot of them off, but it left the opportunity for the rest of us to still go and do whatever we felt we really wanted to do, or to find whatever the coolest thing we could find that was in the corner of the science world and decide to replicate. But like on funding, we had some of the stuff for the chemicals to make the mechanophores already in the chemistry like closets and things, but there was a ton of it that we had to go through and write up that we need this much of this and this much of that. And we're still actually working on the funding for that. We've got it down so that we can make, it's like a 14-step process where there's days where we spend like 20 hours stirring things and slowly raising the temperature. But it's going to be a nightmare to make, but it's going to be really fun. And we've got like enough, we've got it down so we can make the first 2 steps, and then from there we'll work on getting the stuff to make the 3rd step. And I'm sure it's going to take long enough. I'm going to be coming back in the summer, even after I graduate, keep working on this project, just to work on it. So the class, it really gets you involved. Like, I've spent countless hours at my house doing research. It helps you learn how to communicate with people that are just on a totally different level than you. Like, I've had to talk to professors at the University of Illinois. I've had to talk to a professor that works in the UK just to get the information that we need, because we're well beyond any help that Byers could give us at this point.
That's pretty much true.
We've got a grasp.
I'm pretty good at my chemistry, but
we've got a grasp for the super professors in their field, and they are more than ecstatic to hear that a high school student wants to do what they've been working on in a cave for the last 70 years.
And doing it faster too, I might add. You guys are actually learning and making this happen faster than what research professors at major research universities can make happen. So they're very interested in what these kids are doing, because they're actually steps ahead of them in their own research.
And as you can imagine, with their process, there's a lot of downtime, you know, especially while they wait for me to try to figure out how to find these obscure chemicals. And one of the things that I always think it blows the principal's mind, because people stop by our room a lot. I mean, they're intrigued by the printer, but they're just, nobody understands what's going down. But they'll walk in and tell us about some of the stuff you guys have done, because they have downtime, but they can't sit. They're not that kind of people.
Well, we made a Van de Graaff generator. Out of, Byers said earlier that we tore apart about 6 printers.
We were originally trying to turn them into bioprinters, but after a while we were like, we have no idea what we're doing, so we moved on to cooler things.
We pretty much used parts from that to make a working Van de Graaff generator, and then the whole research part, if you're just making stuff and not recording anything, it's just you messing around. It's not science. So we had to actually kind of show that we did that. So I was looking up papers and doing research, and I was like, oh, there's all the science papers are in this format, APA format, and I have no idea how to write that. So I had to just take a couple days, and I wrote like a 15-page paper on this Van de Graaff generator. So maybe we're just messing around doing this stuff, but we're learning more. I'd say 10 times more than in any other class, and it's actually usable for our future. So.
Yeah, and then on top of the Van de Graaff generator, not only the mechanophore group, but also like the scan group, like Theo there, when they get done doing stuff and they've got like downtime or they're waiting for the next project from the 3D printer or whatever, like we've dismantled so many just old things that just no longer have a use. Like we took apart this old broken like bug zapper thing, and now we've got like a Tesla coil that we built and we soldered it all together. We actually built a speaker.
Yeah, we built this sweet speaker like cardboard phones, like 3 little small speakers and then this one huge one. We just put it all together in a cardboard box.
It's all soldered up.
Every day we just bump it.
It shakes the
It's got a headphone jack so we can plug iPods into it. We provided entertainment while we do our research. So we've got entertainment.
But that's like what I was saying. Like people love coming to this class. Like you can see that they love what they're doing. 15 pages, 32 pages. That's them enjoying what they're doing. You don't see a kid going to a math class or a chemistry class that's required and write a 30-page paper on their own for their. That's just like being pushed upon them. Like they don't want to do that. It's not anything they enjoy doing. They love what they're doing and they're doing it for themselves. They want to be there. They want to learn. They want to research. That's just like how it is. Like that's like our aspect of how learning could change or it can like is changing. That this can happen. Like obviously we had the ACT, the SAT, the plan, the MME. We all have that. It's all standardized. That's how you get in college. That's how you per se set your life up. If you don't do well in the ACT, it's presumed that you're not going to be successful. If you get a 19, you're not going to go to the most prestigious university. If you get a 33, you can go to Harvard, Yale, NYU, or anything like that. But this is like here, if you have a kid that can get a 33 on their ACT and has these brilliant ideas but can't portray them to anyone, they can't talk to anyone, they can't get their information out to anyone, then what good is it? Like how is that good? Well, if there's an average, like we're average, above average, just normal students at DeWitt, what if we 26 through or 23 through a 33 on the ACT, what if we can learn what we're doing and portray it to everyone? But we also have this class instead of a Calc 2 class, AP Calc. What if we have this where we're not just learning for the ACT, but we're learning so much past the ACT? We're learning real life things. Like the ACT is, once you're accepted into college, all the seniors here are accepted into college. What's the ACT good for me now? Like how's that, does that help me right now? Is that, it got me into college, but is that gonna help me get my job? If they wanna see my ACT, I guess they can see my ACT, but they wanna see me speak. They wanna see like my customer service, how I'm gonna act, how I'm gonna talk, everything like that. That's like the difference between us. Like all of us now are experienced. You've seen all of us talk to all you guys. None of us are scared. None of us, like we want to be here just as much as you want to be here. And that's just like one of our main things.
That's one of the best things about the class. I mean, it's a science class, I guess, but there's business, there's science, there's communication skills, there's research development, there's writing, there's so many aspects of this class. I mean, he's one of the science teachers. He's teaching us 5 different subjects of one class.
I actually don't teach.
When people say, why do you love it? Why can't you stop? It's because we do what we love. I can't wait for the business aspect of this, like selling our products. That's really interesting. And he said we're not very smart. I mean, like 26 in SAT and a 3.4, that's not outstanding, but that's like, look what we did. Like if you put your mind to it and you bust your butt and you work as teams, what this class has taught a lot of us is, one, teamwork can solve any problem, and there's always a solution to a problem as long as you work hard. And you know how many times Sam has said, the printer's done, I'm going home, printer's broke. And 20 minutes later, he's back there like working as hard as he can, we figure it out and just keep going.
But another crazy thing about this is, so the junior, senior, junior, baseball player, football player, tennis player, football player, soccer player, and a hockey player. All of us are all in different clubs. I didn't know those 3 kids before this class. Now I can tell you everything they're doing, everything. Like it's like so much more. Like that's the thing that I'm like trying to portray. Like we're trying to portray. Like being best friends with these guys and those guys. Like it's just so much more. It opens up like everything. Like literally everything has opened up in this class to me. And then having a teacher like Mr. Byers, who like he says he's not a teacher for us, but he facilitates us and he teaches. Like, he's a team member. He's like our manager, I guess.
Captain. Oh, that's nice to meet you. Yes.
I was wondering, you as a teacher, what do these guys get scheduled into your class?
It depends on the year. This year, I believe everybody was an independent study. Last year was an actual course. Next year will be an actual course.
And what do you do if you end up with these wonderful students and 2 that just want to sit there and do?
Well, ironic, actually. For the first time ever, my motivation skills have been put to the test. So normally my kids' passion comes through and they do it. We have it's just weird this year. We had somebody enter our class, and she's a wonderful young lady, and right now she is researching. It's hard to quantify this correctly. I want to say like piezoelectrics and maglev trains, kind of. But she had a much bigger issue, and that's what we've been having to deal with. And her issue that I found a lot more problem with than all of this and what we've been working on is she has no passion. Like literally is not excited about anything. And like her mom and I have had some big conversations. I'm like, what does she care about? What can we use? And she's like, honestly, there's nothing. We've been asking her the same question. She's getting ready to go to college. And, we're like, you're going to college, but you don't want to do anything. And so we've been literally, I'm like, write me a list of 10 things that you love. But I don't love anything. I don't care. Make up 10 things that you can write for me. And she's doing stuff. She's not building or anything, but she's like lately she's been over there on the floor. She sits on the floor in the lab, which is kind of weird, on her Chromebook, and she's researching maglev trains and piezoelectrics. And they said the bioprinter died. The bioprinter died because she was the bioprinter. And she's like trying to work on this bioprinter, and then she was like, I just really don't care about bioprinters. Like, well, don't do that. You've got to do what you love. And so it's been a really long process trying to find what she loves, which is actually, to me, way, way more important than what we're doing. I'm like, you got to know.
She's doing research.
And she's doing her research, and she's doing stuff.
What about the kids that just come in and watch everybody?
Like, we don't have, like, if you want to be, like, we all want to be, like I was saying, all of us would say the same thing. We want to be. If you're in this, if you're going to sign up for this class, you're going to want it. You're going to want it. You want it. Like, it's not, there's probably 20 kids on the waiting list that would also, like, next year for the juniors and sophomores and freshmen that are trying to get into it. There's kids that want to be here. You're not, like, if you don't want to learn something, like, then you're not.
And we had a person drop before the course ever ran. Right. Like, I had a conversation with all of them. I emailed all of them and said, this is what you got yourself into. I want you to know going in that you're not going to have direction. You're going to take ownership of what you're doing, and that you've got to be brilliant. You've got to do something amazing. And this one young lady was like, Mr. Byers, I don't want to be amazing. And I'm like, I'm good with that, but you shouldn't be in the course. She goes, I'll transfer tomorrow. And that was, like, back 18 weeks before the course started. But I was like, if you don't want to come in and go crazy, you shouldn't be part of our group. Because, like I told them, the first thing I want them to do is, like, revolutionize things, change it. And, like one of the things they didn't tell you that I'm sure they'll talk about is, I want them to see we don't have to follow this path that everybody has set. It's not, we made it up. And I go, it's not real. You can do whatever the heck you want, as long as you're just doing it. And they had a huge example of this the last time a couple of them presented. There was, you mind if I get the preamble, then I'll let you talk, because Patrick's not here. We were asked to talk at MSU. Kim was there. And I went to the class, and I said, hey, we were asked to talk at MSU at this conference. I go, I'm busy. I've got a cross-country meet or something. And I go, but they'd like some of you to talk. If you wanted to, great. If you don't, I'll tell them no. And two of them were like, oh yeah, we'll go talk. Because they really like, obviously you can tell, telling people about what they do. And so two of them were like, we'll go talk, what do we have to do? And I'm like, show up at Erickson at MSU at 9 a.m., walk in and say, you're the kids from DeWitt, what do I do? I go, Miss Mathaway, you'll be there somewhere. I go, they'll direct you, you'll figure it out. I go, and then do whatever you want to do. And they're like, okay. And so first off, there's like, no, I'm just like, go. But the cool part was, I keep telling them, if you want to make a business, make a business. You don't have to deal with your ACT and go to college, which I know is weird for a high-level chemistry, physics, calc teacher to say, but I'm like, there's so many opportunities for you. Don't pigeonhole yourself. And what happened at MSU?
I was offered a job where I would get paid like $30 to $40.
To start?
To start.
Him and the other presenter.
Yeah, awesome. And the other presenters. So that's what I was like, that's why.
You didn't know that?
I didn't hear this, no.
Oh, yeah.
Who offered you the job?
I don't even remember.
It was the MSU Tech, wasn't it?
Yeah, it was some IT person at MSU. So that's the thing, like, that's why I'm here today. Like, not to get another job offer, but like, don't get me wrong, but like to prove like that we're like useful in society, like that we're not just students, we're like actually teachers as well. Like we're so much, we want to be so much more than just that student that gets the 4 point or the 3.5 and the ACT. Like I was offered a job and She didn't know my ACT score. She didn't know my GPA. She didn't know my background. She didn't know my parents. She didn't know my last name. She knew my story of what I was doing, what I loved to do. And she came up to me afterwards, didn't ask any questions, and said, "Here, I'd like to offer you a job. Email me, here's my phone number, here's this," to me and another kid. Unlucky, I'm going to Hope next year. He's going to MSU. He's going to take that job. That's more than most kids at college are waiting tables making less than minimum wage. That's pretty miraculous. And when that kid may have a 36 on his ACT making $7 an hour, or the one that loves what he does and is making $40 an hour, like that's what I love. That's what, like, really, like, after that I was like, geez, I can actually do something with this. And that's like, that was a pretty sweet presentation.
I don't think you guys ever. We got 1 point. Right? Wasn't it 1 point?
Yes, I gave you 1 point. That's true.
Like, my mom yelled at me the other day. She's like, "Get up here." I'm like, "What?" She's like, "You have a incomplete in this class." She's like, "Where are your grades?" I'm like, "Mom, there's no grades in this class." She's like, "How? How are you gonna get your A?" I'm like, "Yeah, but it doesn't matter." And I think it was so funny because since we were 9th grade, you gotta get the A. Freshman year, I got a D in science. And we just built a 3D printer, so I mean, I mean, no, the class, it's nothing later.
No, what you doing now is not
But it's like Sam was saying, it's like,
That's what you want.
I guess, yes, grades are important, instruction is important, but, and the ACT is, I think, dumb, but anyway. Building a 3D printer and doing something you love and, like, making a profit off something, I know, I'm sorry, I'm getting into it, but we made a profit off something we made, and we discussed how much we're gonna, like, pay people and how much we're gonna cost. Like, that is so cool to me. And we did that all by ourselves. Well, of course, I have Mr. Rivas, but like,
No, I'm good. Staying out of the way.
yeah, it's like our own little small business world presentation, and we're seniors and juniors in high school, and I think that's pretty cool.
Yeah.
Yeah, I'd also like to say that,
That's fine, please, I have a question.
I'll say, the class is teaching us a lot more, even outside of the projects we're working on. Like, half the class goes to, our next hour is AP Calc. It's like half of us go to that class afterwards. But you'd be surprised, just from us working together, if there's a problem, like yesterday we had a test, and we were in that class before the test, we had every whiteboard in the room, we're teaching each other, we're working together. Just the process of, we've gotten problem-solving skills that just come out of nowhere from all this. It was out of everything we had to, like, overcome. And we've learned to work together in groups just fantastically and work with others. And our communication skills with not only each other, people we know, but I walked in one time and they were on the phone with, like, one of the printer people, like, trying to figure out which one of the leads was positive or negative, just calling, like, customer service. And we've talked to all sorts of people, and we give presentations just fine. So not only are we becoming very, very good at what we want to do in that class, we're getting very good at a lot of other things just on accident. We just happen to come along.
And I want to point out, like, I didn't prep them for this. Like, a lot of people are like, "Man, you prepped those kids." Like, literally, I'm trying to find the text message. That I don't even know which one of you sent it, because you guys gave me, it's a random number. But it was like, "Hey, what do you want us to say tomorrow?" And I was like, "Whatever you want to say tomorrow sounds great." You know, because I was here and I'm like, "Do whatever you want." And they're like, "Well, should we talk about the process we went through, or should we talk about the learning, or what we actually did?" And I go, "It's your present. I don't care." I go, "I'm just going to stand there and smile and be happy." And so, like, literally, I kind of just, but that's what they do. And what I tell people is, they're like, I go, it's when you have that passion, when you take ownership, like when people talk to me about this class, I'm like I am right now, I'm like, ah, I'm so happy and excited about it. But that's how they are, because it's their baby. It's named.
Sadie.
That's Sadie. And this, you probably didn't even see this. It's a little
boy.
It's a girl,
Well,
and it makes things.
It produces.
They thought about it. It wasn't like lost. And I don't remember. Seamus. This was the first thing it ever printed for them. And they're like, "Oh, it's Seamus!" And it had like a little jar that said over it to protect it and a label. It was a very emotional process for us. Well, and the other thing is we force that. I shouldn't say we force, because like I said, there's no thing. I just tell them, you got to document. And like, God, I forget, somebody came to the room the other day and they're like, "What is this?" And we have like this table, and it has like tape on it, and it says, you know, February 2nd, 1st. And there's like a thing on it, and February, you know, 3rd, this. And like, they're like, this is like a timeline of what they built. And I'm like, well, they have to document everything. And I'm like, so they literally have it all like laid out their process as they went through. And then people will go, well, how do you make them document? I go, I don't. I tell them that's what you're supposed to do. And they go, okay, that's what we're supposed to do. That's what we'll do. You know, it's like learn how to write the paper. I go, you need to write a paper. How do I write the paper? I go, I don't know, write a paper. And they go, oh, well, we better figure out how to write the paper because someone's going to see this paper, and so it better make sense. You know?
Which is what my question's about.
Yes.
So you, as far as the facilitating the research portion, you just tell them they need to document and they need to write a paper.
Yeah, I mean, it's classic what he said. We tend to say that a lot. Just you document this. No, then it's just messing around. It's not science anymore. And messing around has its place. And I go, it's okay to mess around sometimes. I go, but if you're trying to be doing science, you better document what you're doing so you can follow your path and do that kind of stuff. But yeah, and as far as like the stuff, like obviously I teach chemistry and stuff like that, so I know a lot of chemistry, but like they came to me and they said, hey, what does all this stuff mean? I go, that's not my job. I go, that's your job to figure out what all this stuff means. And he goes, well, then I'll go teach myself chemistry again. I go, then you should go do that. And so he did, you know, because that's what he wanted to know. You know, that keynote speaker, when he was showing the video, I was like, that's my kids. You know, they want to know it, so they go and they just learn it, and then we buy scotch. No, not really. So, you guys missed that video.
And a couple days, was that this week? We had a Google chat Monday. Last Friday. Yeah, we had a podcast that we did with, who was there?
Martina Raggets, right? Did I say that right?
Regettes.
Yes.
Regettes, thank you.
And then another teacher from the school and
Mr. Cravata
and another lady. And we
Mrs. McVeigh, the technology director. She's the one videotaping.
Well,
it's not awkward, don't worry.
Well, we had a Google chat, and she watched us, like, actually work. I guess that was sort of...
No, you're fine. It's good.
She watched us work, and we had 3 Chromebooks set up around the room, and one was on Mr. Byers, a couple were on us with the printer, and then the mechanical force had their Chromebook too. And we had a chat for about an hour and 20 minutes, around that, hour and 10 minutes, and just about the class, like how, like it was actually like a hand, like we were doing our work, and she was watching us, and she was like watching, like just making
There's a link to it on our Twitter.
And asking us questions just like this, but on a totally different like front on a laptop, not in front of a presentation like this. So that was pretty cool. That was a lot of us. That was the first time we'd ever used Google Plus with the chat room. So we learned a lot of stuff.
And if you're wondering, what you're seeing, like these guys constantly doing, they're actually, this is what actually literally happens in the room. So they're tweaking stuff right now. They're trying to make it work. It has issues from who knows what, and like this is what goes on.
There will be hours of all of us sitting around this printer with about all of us are this close to it in a circle, and we just sit and we try and figure out what goes wrong because every single, I don't think we've had a day yet of printing where something has just gone right. This cube that Byron saw up earlier, this was try maybe 30 on day 3 from the first time we actually got it to extrude filament.
You want to talk about passion? When that printed, that guy like took his shirt off and ran around the room.
I
did.
Yeah.
How long did it take to print that little?
That's like 15 minutes.
That's 15 minutes. But the thing is
no, I know. I thought that's a fun. No, sorry.
To print this, which takes 15 minutes in total, when you get it to go right, took us 3 days and 30 tries. And as Byron was saying, we have things taped down. We had every single attempt taped down to this table, and you can see we had 1 layer, and then 2 layers, and then 4 layers, and it slowly built up, and then all of a sudden we had this cube. We had Seamus. This was our origin. Yes, ma'am.
Are most of the tries and things that you have to repair in the programming, or are they in the machine?
Oh, it's a horrible combination of everything going wrong with it. We will have programs that are wrong that don't necessarily tell it where to go properly, and then we'll have this skip, or we'll have it miss the belt will miss, or our Z-axis here, we have their nuts in here that'll just come off.
One of the most amusing things, personally for me, from the side view, that was hilarious. To them, not funny at all. So it might not be best laugh. But they were making their printer parts. And every piece they made, every piece was this much off. just enough to make it wrong. And they're getting so mad. That's why they designed stuff on SketchUp. Like, that started the process, because they're like, screw this, everybody's doing these wrong.
Because you can download files.
Right, and they're like, we're making our own, so they'd make their own. And then the 3D scanner, that's when they figured out they couldn't scan little things, because they were trying to scan these parts, and they're like, these won't scan, and they're fighting with that. And they're all getting grumpy, and I came in one day, we use spring scales a lot, and kids always take the nuts off those spring scales, and they disappear. And so I came in one day, and it wasn't during class, but there were a couple kids in there, and I said, hey, I need nuts this size. Can you make me some for these things? And they were like, sure. So they, you know, if you give them something that they can do really quick, they'll love to do it. So they're like, okay, and they printed one off, and they're like, here you go. And I go, that doesn't fit. And they're like, oh, you know, that darn printer is always a smidge off. I go, that's not the printer. I'm like, these come by the thousands and thousands. I go, they're standard everywhere. And they're like, it's the programming! And they jump on the computer, they're like, oh! And they're like, we messed up our calibration the first day. And so all of a sudden they're like, you know, light bulbs going off. Then everybody's like in the room, like all of a sudden the room fills up from all these different classes. It works, we figured it out. And they're like printing pieces, and you know, but it was like crazy. Like they were constantly thinking it was the models they were pulling, or that it was the printer doing it. And then they figured it was programming. But these guys, and maybe you haven't either, they never heard of Adreno before. Well, they had to teach themselves how to do Adreno stuff, because that's what the board is. And they're like, what is this Adreno thing? I go, maybe you should find that out. And so, you know, then they do.
Are the mechanic course going to integrate it all with the 3D printer?
Totally separate. I think.
Yeah, totally separate. I don't know what we would put on that.
Well, I guess if you could get that last polymer, you could print whatever you're making out of that polymer.
We are out of time, I think. We're at 2 o'clock. We hit the hour mark.
Yeah.
But if you guys, if there's teachers out here, I would definitely try to integrate this in your schools. It's just changed my life, as you can say. I got a job offer. I've learned so much more. It's changed his life. It's changed all of our lives in like a better aspect. So if you guys are teachers or anything like that, definitely try to integrate it. Do whatever you can. You can email us about our information or anything like that. We are happy to help out.
And we'll be around here for a good half hour or so if you have questions for us. If you want to look at our Twitter, there's not a tremendous amount on there because we're always doing stuff rather than being smart and taking pictures and tweeting. But it's DeWitt, DeWitt, RDL, Research and Development Lab. So it's DeWitt RDL. The hour-long video is on there, which is a lot to watch. But if you want to be like, oh, what are these kids doing? Pick a clip. You can see what they do. All right, but that's the site, and we'll probably post more information. So I know somebody asked about the program. I'll have the guys get on there and tweet the programs and stuff so you can see it on there.
But yeah, if you guys want, we'll be here for like another 30 minutes. So if you guys want to ask any questions, or if you guys ever want to do that summer program, that'd be awesome. For candidates.